This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
Support for this podcast and the following messages come from our friends at the Paul Mueller Company and Hopsteiner. Please thank them. This podcast wouldn't be possible without their generous support.
Paul Mueller Company has been manufacturing quality brewing equipment since 1964. Our innovative design and engineering will save you time, labor, and ingredients, sending money back to your bottom line. Learn more about our new mobile hop module at paulmueller.com. This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Put the two concepts together and see if we can make a sour style of beer that has reduced gluten concentration and that may be a commercially viable product.
This week on the show, can lactic acid bacteria used to make sour beers make your products gluten-free?
Hi, my name is Brett Taubman. I'm a professor in the Department of Chemistry and Fermentation Sciences at Appalachian State University.
Well, Brett, let's start off with some basics before we get into your study. What exactly is gluten?
So gluten is a storage protein that's found in a number of cereal grains. Most people are familiar with it in wheat grains, but it's also found in rye, and it's found in barley, which is of particular concern to the brewing industry. And in barley, it's known as hordenes. The hordene proteins are the storage proteins that cause that immune response in people with celiac disease.
Yeah, and your paper states that these proteins are involved in a range of allergic reactions and autoimmune responses from wheat allergy to celiac disease. Why don't you talk about that range? What does it mean to be gluten sensitive versus celiac, and what else is in that range?
I think that's the $1,000,000 question, and that's certainly outside of my wheelhouse. And I think a lot of medical professionals are trying to figure that out right now, what it means to have a gluten allergy or a gluten sensitivity. I mean, I think having celiac is a pretty diagnosable condition, a disease that is fairly straightforward nowadays to diagnose and determine if someone does have celiac. But that spectrum of these immune responses to gluten, or if it's something else found in the same matrix with gluten, I think that's still being figured out by the medical community, although it does seem to be a real issue with a number of people and a number of different products that are at least related with gluten these days.
From a regulatory perspective, talk about what it means to label products as gluten-free.
Sure. And despite my 1 year of law school before I dropped out, that is also another very sort of complex and confusing area. So the FDA has recommended that products can be labeled gluten-free, and again, this is outside of my wheelhouse, and this would be more of a question for somebody who is a legal expert. But a product can be labeled gluten-free if it is made without any grains containing gluten or any products containing gluten to begin with, and if it also measures below 20 parts per million gluten concentration. What's typically measured is the prolamins, which is a broader class of these proteins. if it's made without these gluten-containing grains and it's 20 parts per million or less, it can be labeled gluten-free. If it is made with gluten-containing grains, for example, a beer that's made with barley that contains hordein or gluten in there, and then it measures 20 parts per million or less after it's been packaged, then it can be labeled in a fashion that says, gluten reduced, and this product has been made with gluten containing grains and has then, been subject to some processing that has reduced the gluten content in this product. There's also another classification. If it's 100 parts per million or less, I don't know if that's a legal classification, but that's also considered gluten reduced. So anything that's 100 parts per million or less is considered to be somewhat low in gluten concentration, and then 20 parts per million or less is essentially considered gluten-free. However, that is kind of an issue when it comes to measurement techniques, because it's been shown that a lot of the assays that are used, and the one, in fact, that is accepted by the FDA as the accepted measurement for gluten concentrations, has been shown to be not as accurate as it could necessarily be. And it's not because it's not necessarily accurate in identifying what it's supposed to identify, but that people with celiac or with certain gluten sensitivities can actually have that immune response to even smaller units, single amino acids, or two amino acids together, can have a response to, those very, very small peptides as a result.
There are lots of gluten-reduced beers available, most of which are produced with the Brewers Clarex. What motivated you to examine the possibilities for reducing gluten with lactic acid bacteria?
The short answer is why the heck not? But I think, and you're right, using a product like a Brewers Clarex to reduce those storage proteins after the fact, has been shown to do a great job in reducing those proteins, even though that wasn't the original intent of that product.
Right.
That being said, and great beers are being made using that product. We kind of looked at it from the viewpoint of, sour styles of beer have become very popular in the last several years. And we were aware of the fact that, and most of sour beers are soured using lactic acid bacteria. And we were aware that lactic acid bacteria are capable of reducing gluten concentration, of actually metabolizing those storage proteins. So we, one of the big studies was looking at lactic acid bacteria in sourdough bread production, and how some of those lactic acid bacteria species actually metabolize the gluten in that sourdough bread. So we said, why not take this popular style of beer and these lactic acid bacteria that are known to be able to metabolize gluten, put the two concepts together and see if we can make a sour style of beer that has reduced gluten concentration and that may be a commercially viable product.
We'll talk about how you set up the experiment and sort of the bacteria that you selected.
Sure. So we took, there were 5 bacteria that were identified in that sourdough study. We took 4 of those because those were the 4 that were fairly straightforward to obtain. So 4 lactobacillus species, Plantarum curvatus brevis, 3 lactobacillus species, and then Pediococcus pentosaceus. So we took those 4 bacteria, which are easy to obtain. We set up a study where we did, one set of batches. We did one batch which was just a control. where we brewed our wort. And then we added just a Saccharomyces cerevisiae strain. We called that the control. And then we did batches with the Saccharomyces species along with the bacterial species, those 4 bacteria. And then we did that same wort, and we fermented those just with the individual bacteria.
Coming up.
Really, after about 5 weeks, a couple of the bacteria had already dropped below detection limits for the assay that we used.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas. This episode is brought to you by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
And here's what's coming up on the Master Brewers calendar. The District Michigan Summer Social is July 7th at Fitzgerald Park in Grand Ledge. District Northern California meets at Admiral Maltings in Alameda July 19th. Don't miss the Brewery Safety Webinar July 25th. District St. Paul, Minneapolis joins forces again with the Minnesota Craft Brewers Guild for the 5th Annual Business and Technical Conference July 27th in Duluth. The annual District Texas Summer Meeting is the weekend of August 3rd in Kerrville. The ASBC MBAA Brewing Summit takes place in San Diego this August. Discounted early bird registration closes June 19th. Register at mbaa.com, where you can also view the full count of events with more details or find a district meeting near you. Now back to the show. Walk us through the control beer and sort of its gluten levels throughout the process.
Sure. So we started for all the beers for the wort, started at over 500 parts per million gluten. So it had, we wanted to make sure that the initial batch started with essentially as much gluten as we could pack in there. And that was based on our malt bill that we used. So then, like I said, we took that batch, divided it up into 9 different fermentations, the control, the yeast with those 4 species, doing a co-fermentation, and then the individual 4 species. And we looked at the gluten reduction over time, and we measured that on a weekly basis for 7 weeks. So that initial drop was about the same for all of them. So we went from over 500 parts per million gluten to a little over 100 parts per million gluten in pretty much all of those batches. Some were a bit higher than that after the first week, but after the first week, we saw a fairly large drop in gluten concentration, which is not surprising, and we assume that's due to the cold break, which is just those smaller molecular weight proteins that will fall out of solution during fermentation or post-primary fermentation as that sediment on the bottom of the fermenter. And this is, the smaller molecular weight proteins and peptides relative to the higher molecular weight proteins and peptides that fall out during the boil, or that should fall out during the boil, which is referred to as the hot break or trube. So hopefully most of the higher molecular weight stuff is removed during that hot break after the boil. and then prior to being put into the fermenter. And then you have additional material, the smaller material that was too small to sediment out during that hot break. So that typically falls out, in the first several days of fermentation, or like I say, post-primary fermentation, after you the vigor of the boil sort of, or the vigor of the ferment sort of settles down. So we saw that sort of steep reduction to begin with, and then for the batches that were done with the yeast, with the control yeast, the Saccharomyces cerevisiae, we saw in most of the batches a fairly small reduction, but none of them really got below about 100 parts per million, even after 7 weeks of fermentation. Whereas with the bacterial batches, just the bacteria itself, we saw a fairly steady reduction over that 7-week period. And really, after about 5 weeks, a couple of the bacteria had already dropped below detection limits for the assay that we used. And then the other 2 bacteria, after another week, had dropped below detection limits, whereas the control remained up around 100 parts per million, or a little bit more than that. So there didn't seem to be any metabolic reduction of the gluten in the batches that contained the yeast in there.
Why do you think that was?
Well, I think, Saccharomyces cerevisiae will generally outcompete lactic acid bacteria. So that'll kick off first. They'll use up a lot of the nutrients that are in there. So the lactic acid bacteria aren't able to really take hold in there and ferment anything. When we remove the yeast from that situation, the bacteria had access to those nutrients and were able to ferment that material themselves. And you see that in any fermentation, right? I mean, the key in brewing is sanitation, not sterilization. You're never going to get a completely sterile batch. There's always going to be some bacteria present. The idea is to outcompete that bacteria with the yeast that you're trying to ferment with, to outcompete that and to use up any of the nutrients that would otherwise be available to those bacteria. So short of a metabolic study, we did seem to see a reduction in gluten by those lactic acid bacteria, whereas all of those batches with the yeast, the gluten only seemed to be reduced due to sedimentation of the hordein proteins during fermentation.
And so, how low did those get? They also never really got much below 100, or?
No, they all stayed right around 100 or slightly below. So they couldn't be labeled as, gluten reduced. They never got close to that 20 part per million limit.
Right. And is your thinking is that even with extended aging, there's still pretty much no chance they're going to get there?
I mean, it's possible, right? Because, with sour fermentations, and that was one of the things that we considered in this experiment too, is, what's the commercial viability of a product like this, not only from a flavor standpoint, but from a time standpoint. And, a 7-week fermentation is not exactly viable for a standard brewery making standard sorts of ales, for example. But, people with sour programs, 7 weeks is a fairly short time period for putting out a sour beer. So with a longer fermentation or aging time, it is possible that even those batches that had the yeast in there could see a similar reduction if those lactic acid bacteria with limited nutrients remaining could still see somewhat of a fermentation and could potentially reduce that gluten to the limits or to the levels that we saw in the bacteria-only batches.
Yeah, that's interesting. I wouldn't be surprised if this paper prompted some folks to test their mixed culture beers for gluten. Have you heard from anyone that was producing gluten-reduced beer but didn't realize it?
No, but I mean, that's something that we've been looking at for quite some time. And, even standard beers, generally, I mean, depending on the production process, probably not your standard hazy IPA, for example, or a Hefeweizen, something like that. But most standard beers that you see out there have fairly low gluten concentrations just from the process parameters that are used, tend to lower those gluten concentrations. And this is a thought that I've had for quite some time, knowing that lactic acid bacteria are capable of metabolizing gluten. Is one of the beer styles that I've been looking at is sour beers. So we have tested a number of sour beers over the years and have found that a number of them have gluten concentrations that are below detection limits.
This study also evaluated other process variables during mashing, such as pH, temperature, liquor to grist ratios. Do you want to talk about those results as well?
Sure. Because like I was saying, a lot of the standard process parameters tend to reduce gluten concentrations because, most brewers are trying to reduce protein concentrations to a level that won't lead to microbial instability, haze issues, things like that. You want to leave behind foam positive proteins, but other than those foam positive proteins and some proteins that add to the body of a beer, you want to try and remove most of the protein content from your beers. So we looked at a lot of the standard process parameters, and a lot of them were fairly straightforward. Like the boiling time, for example, we essentially saw a downward trend in gluten concentrations with boil time. So, starting at zero boiling, where you saw high gluten concentrations, up to 120 minutes of boiling, we saw a fairly steady reduction in gluten concentrations in that final product. The fining agent addition was pretty interesting. And this is something that I tell my students all the time. Don't just take the recommended dose of the fining agent as, sort of the law. Do a test to see for every style of beer that you make or every, different beer that you make, do a simple test to determine what the correct amount of fining agent, kettle fining agent is that you should be using for that beer. And we actually found that the recommended dosage for the fining agent reduced the gluten by far the most relative to we did no fining agent. We did half the recommended dosage, and twice the recommended dosage, and found that, the recommended dosage, and we could have done finer sort of amounts than that, which may have shown a difference. But the recommended dosage of fining agent by far reduced the gluten concentration the most. Liquor to grist ratio was also interesting, and again, kind of that standard, 1.25 quarts of water per pound of grain if you're American, or 2.6 liters of water per kilogram of grain if you're European and use the more logical metric system. We found that that sort of
or
standard,
if you're American and use the more logical,
or if you're an American scientist, I guess. But I kind of straddle that fence as an American, beer chemist, because I want to use the metric system as a scientist, but a lot of American brewers, tend to use our American system. But anyway, we found that the sort of standard liquor to grist ratio did seem to reduce the gluten concentration the most. However, at higher liquor to grist ratio, so more water per pound of grain or per mass of grain, we didn't see that much of a difference in gluten concentrations. Mash pH and temperature was a little bit more difficult to explain. We saw a reduction in the gluten concentrations at sort of lower than standard pHs, where typically you want your mash pH around 5.2 at mash temperatures. So it'd be even a little bit higher at room temperature than that. But around 4.5 to 4.75 is where we saw the lowest gluten concentrations, and that may be, a more optimal range for the peptidases and proteases, to activate those to reduce that gluten concentration. Or you may see a reduction in those because then you're actually leaving larger molecular weight compounds that will actually be removed during the hot break or the cold break. So that one's a little more difficult to explain without further studies. And the temperature, mash temperature, we didn't see a huge difference except at the higher end of the scale where, at higher temperatures, we saw an increase in the gluten concentration. But we did see the lowest gluten concentration at your sort of standard mash temperature of 65 degrees Celsius, which translates to 149 degrees Fahrenheit. So mash pH and temperature were certainly more difficult to explain. I wouldn't recommend, based on this study and my experience in general in sort of changing mash pH and temperature. And the other parameters, it seemed to indicate that, sort of sticking with those standard parameters tends to reduce the gluten concentrations the most. So like we were seeing in the beers that we measured, if you're following sort of standard processing parameters, that seems to reduce those gluten concentrations to a decent amount at least.
Very interesting. This is outside the scope of your work, but do we know how much influence beginning barley, protein, and S over T have on gluten levels in the final beer?
Essentially it and these storage proteins, it starts with, the barley species, the variety, the climatic conditions for that particular year, as well as especially fertilizer application. So time and amount of fertilizer, the amount of fertilizer that's applied and when it's applied during the growing season. And I'm certainly not an agricultural expert, and I don't think a lot of fertilizer is necessarily applied to barley throughout the growing season, but that translates directly to especially hoarding concentrations, those storage proteins. So the more fertilizer that's applied and the later it's applied in the growing season, the more will be translated to storage proteins in those grains. So yeah, absolutely. If you have higher protein content in your beer and it can be solubilized, then you will certainly see those gluten concentrations increase in your beer. So if you're, using a lot of 6-row barley, for example, you're going to have more gluten concentration, higher gluten concentration in your finished product, most likely.
Yeah, that's interesting. We just did an episode not that long ago with Joe Hartrick explaining how North American 2-row has essentially taken on 6-row characteristics over time, whereas European barley 2-row has not, and talked about the difference in fertilization practices and protein content. So I think that's a very interesting tie into gluten, because I wonder if that is not is not a major factor in the higher gluten levels that we maybe experience here versus in Europe.
It's certainly possible, and we've noticed the same thing in some of the limited studies we've done with barley in this country, and specifically barley in North Carolina, where we are, where a lot of heritage varieties are being brought back.
Right.
And a lot of them are 2-row varieties. And normally it goes as the drier the climate, the lower the drier the climate, the higher the protein content will be in that barley. So the wetter the climate, the lower the protein content will be. So you would assume, okay, barley grown in North Carolina, which is pretty darn wet, especially relative to, say, Montana, the protein content should be significantly lower. However, we see exactly the opposite And what we think is going on is that while it is a much wetter climate in North Carolina, and this has to do with the solubility of nitrogen in the soil and so forth. So, you assume in a drier climate that nitrogen is going to sit there in the soil because it's not going to, just pass through the soil as it continues to rain and is diluted and gets into the water system, for example. But in North Carolina, there's so much organic material in the soil that we see really high protein concentrations, even in two-row barley in North Carolina.
Going back to your study, did you want to talk about the sensory work that you did?
I mean, I think the flavor profile, and this is something that, we'd want to look at further. And really we were focusing on gluten reduction. We weren't necessarily focusing on making a, delicious tasting beer. That being said, however, the sensory results from the beers with the bacteria-only batches were not super favorable.
Right.
So it would certainly take further work to make beers that are palatable in this style that also have a reduced gluten content. But beyond that, they certainly did have less gluten than the beers that were produced with the yeast only or the yeast and bacteria.
That was Brett Taubman here on the Master Brewers podcast. If you'd like to learn more about this project and study the data, you can find Brett's recent publication by typing gluten into the industry's best search bar at MBAA.com. I'm really looking forward to the ASBC MBAA Brewing Summit coming up this August in San Diego. It only happens every 4 years, and it's not like any other conference you've attended. The Brewing Summit is 100% the science and technology of brewing. No pep rallies or business lectures, and you'll be surrounded by some of the smartest men and women in our industry. If you can only attend one conference in 2018, this should be it. Register now at mbaa.com.